Welcome to today's custom deep dive into the source material. Well, the mission today is to completely rethink a cornerstone of modern physics.
It's a big one today.
It really is.
Yeah.
We are looking at a highly critical document, and this source takes one of the most famous, seemingly unquestionable experiments in all of science, Young's double slit experiment. And it basically argues that the accepted conclusions are fundamentally flawed.
Yeah, and the double slit experiment, or DSE, it is widely taught as the absolute bedrock of weird quantum physics.
The ultimate spooky science.
Exactly. It's the standard proof everyone offers for wave-particle duality. You know, that idea that particles exist in this state of probability until they're actively observed. But the author of this document suggests that we have substituted actual, rigorous boundary physics for, well, a clean, popularized narrative.
A narrative that might just be an oversimplification.
Precisely. To genuinely understand what's happening in the DSE, the source insists we cannot just start with two slits. That's skipping a step. We have to start from first principles and look at a less famous but crucial prequel experiment, which is the laser single slit, or LSS.
Okay, let's unpack this because the author's critique of that single slit really sets the stage for everything else.
It does.
So we all know the standard classical mechanics expectation, right?
Yeah.
If you fire a continuous light beam through a standard macro-sized aperture, you get a localized intensity profile on the screen behind it.
A single band of light.
Right? Very little smearing or diffusion. It behaves, for all intents and purposes, like a stream of particles just passing through a window.
Right.
And the author doesn't dispute that. But they zero in on what happens when you alter the physical parameters of that window.
Yeah. The critical shift occurs when the experiment is repeated, but the width of that single aperture is reduced to the point where it closely matches the wavelength of the incident laser light itself.
And that's when things get weird.
Completely.
Yeah.
When you do that, the downstream profile completely transforms. Instead of a tight band, a broad diffraction pattern emerges. You get these distinct alternating light and dark bands, which is exactly characteristic of constructive and destructive wave interference.
And it's crucial to remember that this is happening with only a single slit.
Only one.
Which is so counterintuitive if you're holding on to a strict particle model. But the author's main point here isn't just, a wave pattern. It's about why that pattern appears in the first place. Because the incoming laser light wasn't modified in midair.
Right, nobody introduced a secondary wave medium or anything like that. No second slit was added.
What's fascinating here is how the document interprets that outcome. The only variable that changed was the physical geometry of the aperture.
Just the physical constraints.
Yeah, and the author argues that the resulting interference pattern isn't some miraculous revelation of the light's hidden wave nature. Rather, the pattern encodes how the light field was forced to resolve the physical geometric constraints imposed upon it by that specific narrow slit.
The instrument itself dictates the interaction.
The boundary condition dictates the wave type character. I want you, the listener, to really visualize this and hold on to that idea. The downstream pattern wasn't just showing what the light was, it was a record of the physical constraints.
Because if a single slit can force a wave-like diffraction pattern purely through its geometry, it heavily implies we might be attributing properties to the light that actually belong to the apparatus.
Which is a massive paradigm shift.
It is, and the author takes this skepticism a huge step further by examining the light source itself. Which brings us to a major assumption the document really just tears down, the myth of the pure laser beam.
Oh man, this part blew my mind. Because I think we all just assume the incident light hitting the slit is a geometrically neutral or like a passive plane of light.
Yeah, we tend to conceptualize it as raw, natural light that has just been neatly organized. The source emphatically states this is a false premise.
Totally false.
The incident laser is actually a wholly artificial construct. It is not an integral geometry, it's a composite.
The phrase the author uses is phase-locked consortium construct, which that is such a specific, dense term. When I read that, it sounded less like a natural phenomenon and more like an engineered industrial product.
That's exactly how you should think about it.
So what exactly does the author mean by a phase-locked consortium?
Well, think about the mechanics of stimulated emission, how a laser is actually generated. Natural light is chaotic. It possesses spatial continuity and internal coupling modes. But to create a laser, that natural light is heavily filtered.
It's processed.
Intensely processed. It's forced to oscillate within an optical cavity, continuously bouncing back and forth through a gain medium and an aperture. And during this process, all the relative phase differences are minimized. Phase gradients are completely flattened out.
So it's stripped of its natural qualities.
Exactly. Furthermore, rotational and torsional modes, which are the natural twisting and turning dynamics of the light field, are systematically stripped away and suppressed. What emerges is not a single natural phase, but this phase-locked consortium.
It's essentially the Hunger Games of photons.
That is an excellent analogy.
I mean, the text literally describes the resulting beam as being composed entirely of survival modes. The majority of the light's natural characteristics are trimmed, truncated, amplified. It lacks the internal coupling modes of natural light.
It is an enforced coherence. The flat wavefront of a laser isn't an intrinsic fundamental structure of light. It's a forced state resulting from extreme physical constraints.
All the internal coupling that exists in natural light prior to lasing has just been actively removed by the machinery. So if we take the author's premise, we're firing an artificial geometrically stripped survival mode beam at a microscopic slit.
Right, and this is the big aha moment. If we connect this to the bigger picture, we start to see a profound compounding effect.
A compounding of constraints.
Yes. The laser itself is already a highly filtered and forced state. It's a product of severe geometric constraints within the laser pointer itself. Then, that already constrained artificial beam hits the narrow aperture of the single slit, which applies even more geometric constraints.
Which means the pattern on the screen behind the slit isn't some profound photograph of the light's inner soul. The author is arguing it's essentially a receipt.
A receipt, exactly.
It is a record of the instrument's design. The screen is displaying a long, complex chain of physical permissions and exclusions dictated by the equipment.
Therefore, treating the experimental setup conditions as purely passive is a fundamental analytical error. If the scientific community ignores the geometric influence of the slit and ignores the highly processed artificial nature of the laser, they are basically setting themselves up to misinterpret everything that follows.
And everything that follows is the main event.
The double slit experiment.
Right. But before we get into the modern interpretation with single particles and quantum collapse, the author provides some really crucial historical context. Because, interestingly, earlier versions of these experiments weren't considered weird at all.
They really weren't. The document grounds its argument in the early 20th century. Back in 1912, Max von Laue and William Lawrence Bragg were observing X-ray diffraction in crystallography.
Firing X-rays at crystals.
Exactly. They saw diffraction patterns, and they correctly understood that the geometry and lattice spacing of the crystals determined the angular distribution of those patterns. It was understood as a purely structural interaction.
The incident waves were just responding to the periodic boundary conditions of the crystal lattice.
Right. Then, the text points out that in 1927, Clinton Davison demonstrated that electrons' actual matter, not just light, also diffract off nickel crystals.
Wait, so electrons were behaving exactly like the X-rays?
Exactly. They responded to the lattice geometry in the exact same way. And the scientific community at the time didn't panic. They didn't invent a new branch of spooky physics.
They just looked at the matter waves responding to the boundary geometry of the lattice and accepted it as standard mechanics.
There was absolutely no suggestion in 1927 that the incident electron had to somehow make a choice about a discrete path, or that its wave function was dependent on an observer. The interaction was governed by the physical constraints of the nickel crystal.
So the whole particle making a choice narrative.
That narrative was grafted onto the physics much later.
Here's where it gets really interesting. Let's fast forward to the modern popularized version of the double slit experiment. Scientists move away from crystal lattices, and they start firing an electron stream through two microscopic slits in a vacuum.
And just like with the nickel crystals, an interference pattern builds up on the screen.
Now, based on the Bragg and Davison experiments, a matter stream creating a wave pattern due to physical boundary constraints really shouldn't be shocking.
It shouldn't be. Yet the interpretation shifted dramatically. The crucial turning point, according to the document, happened around the 1970s.
The observers.
Yes. The scientific community wanted to know which of the two slits the individual electron was actually passing through. To figure this out, they introduced observers, specifically which path coupling devices or electromagnetic detectors placed directly adjacent to the slits.
But hold on, let me play devil's advocate here, because this is the crux of the whole quantum mystery. Even before they added those detectors, scientists were firing electrons one at a time.
They were.
And even when fired sequentially, with massive gaps of time between each electron, the individual hits on the screen eventually built up into a wave interference pattern. How does the author explain away single particle interference without invoking probability?
It's the big question.
Right, because if there's no continuous wave passing through both slits simultaneously, How does a single electron know where to land to form a wave pattern?
That is the exact question the mainstream physics community asked, which led to the probabilistic interpretation. But the source document argues we have entirely overlooked the mechanics of the firing process and the environment itself.
How so?
The author brings up a fascinating historical parallel referencing Rutherford's N14017 data.
Okay, let's unpack that Rutherford reference because the document mentions it briefly, but it feels foundational to their whole counter-argument. How does firing alpha particles at nitrogen gas relate to electrons passing through a slit?
Well, in 1919, Ernest Rutherford demonstrated that bombarding nitrogen-14 with alpha particles resulted in a transmutation into oxygen-17. But the key takeaway the author is extracting here is about harmonic feedback.
Harmonic feedback.
Right. The bombardment wasn't just a series of isolated random kinetic collisions. The continuous firing established a resonant state, a harmonic feedback loop within the target system.
Oh, I see.
So the author suggests that when you fire a stream of electrons at a double-slit apparatus, even one by one, you are not firing into a passive, empty void.
So the apparatus itself is actively reacting to the firing process.
Yes. The continuous firing establishes a spatial harmonic resonance within the boundary conditions of the slits. The physical space becomes conditioned by the energetic history of the experiment.
Wow. So when a single electron passes through, it isn't making some probabilistic choice in a vacuum.
Not at all. It is interacting with a highly conditioned phase gate that is already resonating with the harmonic feedback of the system. The electron is just following the resonant grooves, so to speak, carved by the physical constraints of the apparatus.
That fundamentally changes the entire picture. It means the empty space isn't actually empty. It's an active resonating field shaped by the slit's geometry.
Exactly.
Which brings us back to the 1970s and those witch path detectors. Because when the scientists turned those detectors on to supposedly watch the electrons, the famous quantum collapse happened.
The pattern vanished.
The beautiful wave interference pattern disappeared, and the electrons just formed two clumpy particle bands on the screen. And the mainstream consensus was that the very act of conscious observation caused the wave function to collapse.
And this raises an incredibly important question. What is a detector physically? The author fiercely rebuts this whole witch path mythology, arguing that physicists abstracted the detector into a passive philosophical observer while completely ignoring its physical reality.
It's not just a pair of eyes.
No, a particle detector is a highly energetic macroscopic electromagnetic device.
Exactly. It's not a human quietly watching from the corner of the room.
Yeah.
It's hardware.
If we connect this to the bigger picture, placing an energetic measuring device right at the microscopic aperture fundamentally alters the physical geometry and the electromagnetic boundary conditions of that space.
It changes the constraints.
Pre-1960s evidence already proved that apertures act as phase gates. The text argues that the detector simply introduces massive, overwhelming boundary constraints.
So the author is saying the detector didn't cause a magical quantum observer effect. By turning on a powerful electromagnetic device next to a microscopic slit, the scientists violently altered the physical constraints of the phase gate.
Precisely the author's point. It is no different in principle than what happened when they narrowed the aperture in the single slit experiment. You alter the constraints, you alter the downstream pattern.
It destroys the resonance.
Exactly. The detector swamps the delicate harmonic feedback loops we just discussed. The electron stream, which remember is already a heavily processed phase-conditioned field, interacts with this new massive energetic boundary, and the wave pattern naturally degrades.
It's a completely grounded mechanical explanation. The author is essentially accusing the scientific community of jumping the gun.
They leap to a philosophical conclusion.
Yeah, instead of looking at how adding a massive electromagnetic device might physically disrupt a delicate resonant field, physicists invented a narrative where particles possess this quasi-conscious awareness of being watched.
The document is uncompromising on this. The idea that a particle must choose a pathway, or that reality depends on an observer, introduces an entirely unnecessary philosophical influence.
Especially when the classical physics already had an answer.
Exactly. Known boundary physics, how waves, fields, and highly conditioned energy streams interact with physical structures, was already established and fully capable of explaining the phenomenon without resorting to weirdness.
So what does this all mean for you, the learner? Let's synthesize the core argument here. If the logic of this document holds, the entire foundation of popularized quantum mechanics, might be sitting on a misinterpretation of a single experimental setup.
It's a sobering thought.
Particles do not make clever decisions. An electron is not aware of your gaze. We may have invented a century of Stucky action simply because we forgot how to account for the physical interference of our own instruments. We treated an active geometric filter as a passive window.
And I think the true value of this document isn't just in its specific critique of the DSE. It's a masterclass in critical thinking and scientific skepticism.
It really makes you question everything.
It forces us to examine the assumptions we silently carry over from one experiment to the next. When we fail to account for the highly artificial, constrained nature of our sources, like the phase-locked laser, and when we ignore the active boundary conditions imposed by our detectors, we skew our entire model of reality.
We confuse the tool with the truth.
Exactly. We must not confuse the physical limitations of our instruments with the fundamental laws of nature.
The tools we use shape the reality we observe. Keep your curiosity sharp and never stop questioning the clean narratives.